Water towers are everywhere. You can spot them rising above neighborhoods, standing beside highways, or overlooking small towns and large cities alike. Most of us pass by them without giving them much thought, even though they're one of the hardest structures to miss. Their unusual shapes almost seem random, but every curve, every support beam, and every bit of height has a purpose. So why are water towers shaped that way? Let's find out right here on History of Simple Things. At first glance, a water tower appears to be nothing more than a giant container balanced high above the ground, but its purpose goes far beyond storing water. The real reason water towers exist is to create water pressure. Whenever you turn on a faucet, flush a toilet, or take a shower, water has to travel through a network of underground pipes before it reaches your home. Instead of depending on massive electric pumps every second of the day, most water systems let gravity do much of the work. Gravity is always available, it never runs out of energy, and it doesn't cost anything to use. By placing a large amount of water high in the air, gravity naturally pushes that water downward through the pipes. That downward force is what creates the pressure needed to deliver water to homes, schools, hospitals, offices, and fire hydrants. This idea may sound surprisingly simple, but it has been one of the most reliable engineering solutions for centuries. Modern cities still use the same basic principle because it works exceptionally well. Many people assume that a bigger water tower automatically means stronger water pressure. In reality, that's one of the biggest misconceptions. The amount of pressure depends primarily on the height of the water, not the total amount stored inside the tank. Imagine placing two identical buckets on different shelves. One sits on the floor, while the other rests on the roof of a building. If both buckets are connected to hoses, the higher bucket will produce much greater pressure simply because gravity has a longer distance to pull the water downward. Engineers measure this pressure in pounds per square inch, commonly called PSI. Roughly speaking, every 2.3 feet of water height produces about 1 PSI. That means a water surface positioned around 115 feet above your house generates close to 50 pounds per square inch, which is an ideal pressure for many residential plumbing systems. That's why water towers are built so tall. Their height, not their width, is what keeps water flowing smoothly whenever people need it. If height is so important, you might wonder why engineers don't simply build a very tall pipe completely filled with water. The answer comes down to storage. Cities need more than pressure. They also need a large reserve of water that can handle sudden spikes in demand. The tank at the top acts like a giant storage battery. During the middle of the night, when relatively few people are using water, pumps gradually refill the tower. Then, during busy mornings, when thousands of people shower, brush their teeth, prepare breakfast, and start washing clothes at nearly the same time, the stored water helps satisfy that temporary surge without requiring the pumps to work overtime. Without the elevated tank, the entire water system would have to rely almost entirely on continuously running pumps capable of meeting the highest demand at every moment. That would be much less efficient and far more expensive. Now let's answer the question most people actually notice. Why do so many water towers resemble giant mushrooms? The shape is a clever balance between strength, stability, and construction cost. The supporting column underneath is relatively narrow because engineers want to use as little material as possible while still safely supporting the enormous weight above. Making the entire structure thick from top to bottom would require far more steel or concrete, increasing construction costs dramatically. Instead, the large tank sits on a slimmer support structure that carries the load efficiently. The rounded tank itself also serves an important purpose. Curved surfaces spread the tremendous weight of the water more evenly than flat surfaces do. This reduces stress concentrations that could eventually weaken the structure. Not every water tower follows the classic mushroom design. Some resemble giant golf balls balanced on tall stems. Others are shaped like large spheres, cylinders, cones, or even giant bottles advertising local industries. Despite their different appearances, they all rely on the same engineering principles. Spherical tanks are especially efficient because pressure is distributed evenly across the entire surface. This allows engineers to build strong tanks while using relatively less material. Cylindrical tanks are also popular because they're easier to manufacture and expand for larger capacities. Sometimes appearance plays a role as well. Many communities transform their water towers into landmarks by painting them with city names, mascots, fruit, animals, or local logos. Some towns become instantly recognizable because of their unique water tower, making these structures both practical and symbolic. A common question is what prevents a water tower from overflowing if pumps are constantly adding water? The answer lies in automation. Modern water towers contain sensors that continuously monitor the water level inside the tank. As people throughout the community use water, the level slowly drops. Once it reaches a predetermined point, pumps automatically switch on and begin refilling the tank. When the desired level is reached, the pumps shut off again. This process happens quietly every day without most residents ever noticing. Because the tower stores such a large reserve, the pumps don't need to respond instantly every time someone turns on a faucet. Instead, they work steadily and efficiently over longer periods. The next time you spot a water tower rising above the skyline, you'll know its unusual shape isn't just for appearance. Its height creates the pressure that delivers water to homes and businesses. Its rounded tank safely supports millions of pounds of water while using materials efficiently. Its stored supply helps communities handle busy mornings, power outages, emergencies, and even fires. It's a brilliant example of how a simple idea, using gravity instead of constant mechanical force, can solve a complex problem with remarkable reliability. Water towers may never become tourist attractions, but they remain one of the smartest pieces of everyday engineering ever built. Quietly, day after day, they keep clean water flowing with almost no one noticing. And perhaps that's the greatest sign of good design, when something works so well that we forget it's even there. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.